When the local temperature display ticks up to 48 degrees Celsius, a bright summer afternoon physically distorts. The air ripples above the asphalt, traffic slows to a crawl, and the city begins to feel more like a sealed oven than a place to live. Unlike an earthquake or a hurricane, there is no roaring wind or collapsing infrastructure. The buildings stay perfectly intact. Yet this quiet, invisible weather event kills more people than almost any other natural disaster. In the summer of 2003, extreme heat settled over Europe. Hospitals were completely overwhelmed by dehydration and heat stroke cases, leading to an estimated 70,000 excess deaths across the continent. High temperatures also act as a catalyst for compounding catastrophes. During the 2010 Russian heatwave, the scorching weather ignited vast forest fires, choking Moscow in a thick, hazardous smog and destroying billions of dollars in crops. To see how familiar hot weather turns into a mass casualty event, we have to look past the thermometer. We have to trace the heat from the highest levels of the atmosphere down to the biology of the human body. Nearly all the heat on Earth starts as solar radiation. Sunlight beams through the sky, strikes the surface, and warms the land, the oceans, and the air immediately around us. The distribution of heat is managed by the jet stream, seen here as a high-altitude river of wind. Normally, it keeps weather systems moving, but when the jet stream slows, it can trap a weather pattern over one region for weeks. As the system stalls, a massive column of high-pressure air builds up. This sinking air acts exactly like a heavy, invisible lid pressing down on the landscape, creating what meteorologists call a heat dome. Because this sinking high-pressure air prevents clouds from forming, solar radiation continuously blasts the surface. When that newly warmed air tries to rise, the high-pressure lid aggressively pushes it right back down, forcing the energy to accumulate. The temperature climbs higher every single day. Rather than simply blowing in from elsewhere, the deadliest heat waves form as inescapable physical traps, constructed in the atmosphere miles above our heads. Down on the ground, the environment usually has a way to fight back. Under normal conditions, some of that intense solar energy is used up evaporating moisture out of the dirt, which naturally cools the surrounding air. But if a region is already experiencing a drought, that cooling system breaks. Without moisture to evaporate, the sun's energy bakes the dry, cracked earth. The ground heats up rapidly, pushing extreme temperatures right back into the air. Humans have built their own version of this dry, barren landscape, creating massive amplifiers for extreme heat right where most of the population lives. You can see this clearly in a dense urban center. Concrete, asphalt, and tall buildings absorb huge amounts of solar radiation throughout the day. When the sun goes down, the city radiates all that stored energy, keeping the streets several degrees warmer than the surrounding countryside. When a high-pressure heat dome parks directly over a parched landscape or a densely packed city, the trap is fully set. The environment absorbs the heat, holds it, and offers its inhabitants absolutely zero nighttime relief. This constant, inescapable heat eventually pushes human biology past its limit. That limit is measured by something called the wet bulb temperature, which you can see illustrated here by comparing a standard thermometer to one wrapped in a wet cloth. Our bodies cool down by sweating, but as humidity rises, sweat stops evaporating. Without that evaporation, your body cannot shed heat, and your internal temperature climbs rapidly toward lethal heat stroke, regardless of how much water you drink. This physical stress extends to our infrastructure. Prolonged heat causes roads to soften, power grids to overload under the surge of air conditioning, and steel railway tracks to expand until they buckle completely out of shape. The extreme temperatures also penetrate hidden ecosystems. On land, the heat destroys crop yields, and in the oceans, prolonged marine heat waves trigger massive, deadly coral bleaching events across vast stretches of reef. Grave. A severe heat wave is a simultaneous, system-wide failure. It attacks human biology, physical infrastructure, and the natural environment, all at exactly the same time. Despite being highly lethal, heat waves present a unique advantage. They are incredibly predictable. We usually know they are coming days or even weeks in advance. This thermal map shows exactly how scientists use Earth observation satellites and high-resolution models to track surface temperatures. By mapping these heat patterns, meteorologists can identify a forming heat dome long before it threatens a population. With that advanced warming, cities can deploy active defenses. Planners are planting urban green spaces to provide shade and installing highly reflective, cool roofs that bounce solar radiation back into space, actively neutralizing the city's trapped heat. Government coordination is just as crucial. In regions like India, which experiences severe pre-monsoon heat, state-run heat action plans combine early warning systems with public cooling centers and enforce outdoor work restrictions to drastically cut mortality rates. Shifting global climate patterns mean these atmospheric traps will only grow more intense over time. But by understanding the meteorology of a heat wave, we can design smarter infrastructure, prepare our communities, and ensure a stretch of hot weather doesn't have to become a deadly disaster.